This is Tech Math 2, and we're in section 6-2, and we're solving systems of linear equations that look different. All right, well, that seems like a reasonable thing to do. So we'll start with number 1, and we'll say, well, I got ax plus y is equal to b, and I got bx minus y is equal to d. I do? I do. All right, well, clearly I can't put it in my computer because it's not going to do it. It doesn't like that. But if I were to add these guys together, I would have a plus b x is equal to b plus d. And then I could have x is equal to, that doesn't look like a d. It looks more like something that isn't a d. Then I can say that x is b plus d divided by a plus b. And that would be my x solution. Now how am I going to get y? All right, I'd pull that back up here. And I say I have a b plus d divided by a plus b minus plus y is equal to b. And then I'd have y is equal to b minus a b plus d over a plus b. And then I'd say, well, I could find a common denominator. I could bring them together as fractions, or I could just say that's my answer. And so I would probably just say that's my answer. I don't see any particular reason to not accept that as the answer. All right, number 3. X plus y is equal to a squared plus ab, and ax is equal to by. Again, not something I could put in my calculator, but I could put it in Maple, so I'll go and turn Maple on and then let Maple come up on solving this problem and see if Maple and I can agree. Well, let's see. I could say, from this equation, I could say that x is equal to by over a. And then with that, I could plug that up into here, and I'd have by over a plus y is equal to a squared plus ab. And then I could say that I could divide this by a and multiply by a. So I could have a plus b over a times y is equal to a times a plus b. And then I could say y was equal to, I'm going to invert and multiply. So I'm going to have a plus b times a over a plus b. Those guys can go away. So y is going to equal a squared. So I have y is a squared and b. Okay, so if y was a squared, then x would be ab. So I got ab as my x, and I've got a squared as my y. And then I say, well, that's nice that the instructor did that. Let's see whether or not Maple thinks that that's the case. So I'm going to solve. And I've got x plus y. Where's x? X plus y equals a squared plus b plus ab, a times b. And then I've got AX, A times X equals BY, B times Y. All right, I'll put a bracket around that, and then I'll put a comma, and then I want, I think I want this guy, but I'm not sure. A, B, XY, X, Y, close parentheses, syntax error. No, no syntax error, but also no solution. Thank you, Maple, for all of your support and everything that you do. All right, so did I misspell solve? What part of this don't you understand, computer? All right, well, and then I'll go to Maple help. And look at solve and see whether or not I'm doing it right. Alright, so solve equations for, alright, so I have solve, and there I have brackets around something. Okay, so here I have multiple equations. Okay, the brackets, I want brackets. I don't want parentheses. Okay, so back to our original guy. Maple was just doing what I told it to do. It wasn't trying to hose me over or anything else. It's just that, thank you very much. There is no solution. Oh well, that's pretty cool. I am very impressed, Maple. So, there is no solution. My solution's obviously the right one. That begs the issue, did I do it right? Are the odd ones in the back of the book? Yes, they are. 6-2. Chapter 12, Chapter 10, Chapter 6, 6-2a. No, the author says the answer is x is AB and y is A squared. Oh, well, that spent $120 for a computer program. I'm not going to do that anymore. Okay. Why don't we do number 10? Well, this is curiouser and curiouser. I put the problem in right. Wow. Anyway, gonna have to think about that some. Yeah, we'll move down to 10 because that looks like a nice hard one. Number 10. A plus B x minus A minus B y for AB. Sure. A minus B x minus A plus B y is equal to 0. What are we going to do about this mess? Now, if we, let's see, check this out real quick. If we were in section 6.4, this would not be a problem. 6.4, we have a method to solve this problem, and it would work just fine. But we're not in that section yet, so we can't use that method. Looks like we'll use substitution. X is equal to 4AB plus A minus B y divided by A plus B. Okay, so I got that from the first equation. We're going to substitute that into the second equation. If I substituted this back into the first equation, what would happen? I'd end up with 0 is equal to 0 and have nothing. So I can't do that. So I get, when I do substitution, when I do substitution, I isolate a variable and from one equation, and then I put it in the other equation. Otherwise, I would not have anything. All right, so I've got a minus b times x for ab, a minus b, y, a plus b. I don't need a bracket down there. Okay, so that's the x guy. Minus a plus b y. Equals 0. Well, isn't that convenient? Just totally, completely convenient. Okay, well, why don't we multiply everything by, no. Yeah, we'll multiply everything by a plus b. And that way we get rid of that a plus b. So I've got 4 ab, a minus b, plus a minus b squared y is equal to a plus b squared y. Well, finally some progress here. All right, so I've got 4a squared b minus 4ab squared plus a squared minus 2ab plus b squared y equals a squared plus 2ab plus b squared y. Okay, well, I've got a plus b squared y and a plus b squared y on both sides. So they can go away. That a squared term can go away. Okay. And then I can take this guy and send him over there. All right, so I got 4 a squared b minus 4ab squared is equal to 4 ab y. And then I can have y is equal to a minus b. Okay, so y is equal to a minus b. Excellent. And this is number 10, which means the answer's done in the back of the book. So the only thing you can do is wave your head and say, yeah, brilliant instructor has it right. All right. Now that I know what y is, I'm going to come back and find what x is. So back up here, I have a equation for x. And we're going to move it back here closer to our equation for y. Okay, and we're going to say that x is equal to 4ab plus a minus b squared divided by a plus b. Because when I put y as a minus b in there, I get a minus b squared. I got 4ab a squared minus 2ab plus b squared over a plus b. I got a plus b squared over a plus b. So I have y is equal to a, I already know what y is. X is equal to a plus b. Okay, so I know y is that, and x is that, and y is this. Okay, well, that's fine. We'll check it. We'll see if it fits in one of the equations, see if it works. So if I have a minus b times a plus b minus a plus b times a minus b, am I going to get 0, yes or no? And the answer is yes. So it checks in the second equation. When I put it in the top equation, I get a plus b minus a minus b, and that's supposed to be 4ab. Okay, so I got a squared plus 2ab plus b squared minus a squared minus 2ab plus b squared. And that in fact does equal 4ab, so everything's fine. So I can put it back in the equation and check it, and I'm not going to waste my time in Maple because Maple already shafted me on one of the easier questions. Why should I ask him to do this one? All right, number 13 is next. 3 over x plus 2 over y equals 0. I like the 0. That's very nice. 2 over x minus 5 over y is equal to 19. Well, I don't particularly care to have these things over x and over y. So I'm going to multiply both sides of the equations by xy. And when I do that, I'm going to have 3y plus 2x is equal to 0. And I'm going to have 2y minus 5x is equal to xy. All right, now, oh, you want a 19 there too. So you're just so picky, so early in the morning. You know? I could have made it all the way through this problem without the 19. Well, thank you for telling me about that. Otherwise, I'd be hosed. Anyway, so I look at those things and I see that this is the equation of a line, right? And when x is 0, y is 3, and when y is 0, x is 2. Well, when x is 0, y is 0, so it's passing through that point there. That's better. And it's got a slope of minus 2 over 3. Minus 2 over 3. Something like that. And minus 2 over that. And then this guy here, with the xy in it, I'm not sure what that is right offhand. I'm thinking that that's some kind of a hyperbola thingy. Anyway, so what are we going to do? I can't get rid of x. I can't get, oh, substitution, of course. All right, so from this equation, I know x is equal to minus 3y over 2. So then I'd substitute in that one. 2y minus 5 minus 3y over 2 is equal to 19 minus 3y over 2 times y. Isn't that lovely? Now, I notice that I have a y in every term, so the y can go away. Isn't that great? So now I've got 2 plus 15 halves. 2 plus 15 halves, that's 2 plus 19, that'd be 19 halves. So I've got 19 halves is equal to 19 times minus 3 over 2y. isn't that convenient. I can divide by 19, I can multiply by 2, and I can say that y is clearly minus 1/3. And this is problem 13, so now we can look at the back of our book if we wanted to. Okay, so y is minus 1/3. I'm going to substitute that into the second equation and say y is minus 1/3. So minus 2 over 3 minus 5x is equal to 19x times minus 1/3. And I'm doing the same thing we've done in the past. I've multiplied by 3 to get rid of the denominator. Minus 2 minus 15x is equal to minus 19x. Okay, so the 2 minus 2 goes on the other side. It becomes a 2. The 19 minus 19 goes the other side. It becomes a positive 19. And we have x is equal to 1/2. So x is equal to 1/2, y is equal to 1/3. And now we honor the back of the book because we don't trust the grad student at all, because he normally gives us the wrong answer. And but he does say it's 1/3 and minus 1/2 and minus 1/3. So the grad student who made up the answer key without any supervision got it right again. I don't believe it. Hard to believe that that would happen. Okay, that was good. Should we do an even one, then we don't have to worry about the back of the book? Yeah, why don't we do that? We'll do 16 next. Then we just say my answer is right and move on. Is that a good idea? No? Wyatt thinks we ought to do 15 so we can check up on the instructor. All right, 15. That's fine. You can think that way. 1 over x plus 1 over y is equal to 13 over 6. And 1 over x minus 1 over y equals 5 over 6. All right, well, normally I'd say we'd do a substitution, or we'd get rid of the denominators, or do all kinds of other weird things, right? But because I've got a plus 1 over y and a minus 1 over y, I'm just going to add those guys together. 2 over x is equal to, are they both positive, really? Yeah, they are. 5 plus 3, so that's 18 over 6, which would be a 3. And then I'd say x is equal to 2/3. Oh, that was okay. That worked out real nice. In fact, that worked out so nice, we're going to do it again. So I got 1 over x plus 1 over y is equal to 13 over 6. And I've got 1 over x minus 1 over y is equal to 5 over 6. And I'm going to subtract the bottom guy. Yeah, there we go. I'm not going to add him this time. I'm going to subtract him. All right, so I got 2 over y is equal to, is that an 8? 8 over 6. And then I'm going to have that y is equal to 12 over 8, which is 3 over 4? No, 3 over 2. Yeah, 3 over 2. So y is 3 over 2, and x is 2 over 3. Wow! And we'll do a grace the back of the book again. See if the solution manual, if the author bothered to get the right grad student. Wow, 2 in a row. Okay, well, that was okay. We probably want to write the solution different, right? We're going to write the solution 2 over 3, 3 over 2, something like that. Final answer. Good, well, 18. Uh, 24 over m 18 over n. This is terrible, because how are we going to know the difference between my m and my n? Now, as obviously, as we move on with the problem, they're going to be the same number. M plus 45 n 116. Okay. Why don't we go and multiply the top guy by 3 and multiply the bottom guy by 2 and subtract. Why don't we do that? 3 times 64 is 72. 2 times 36 is 72. So this guy goes away. Okay. And then we've got 18 times 3 minus 90. 18 times 3 minus 90. So it'd be minus 36 over n is equal to 3 times 72 minus 2 times 116. Minus 16. Minus 16. That boggles the mind. 3 times 18 minus 90 minus 9, and 3 times 72 minus 2 times 116. All right, well, that's what it is. All right, so n is going to be 36 divided by 16. 4 goes into both 4/9. Okay, so n is 4/9. I come back up and see that, should I do it again or not? I think I'm going to do it again. Thank you very much. So I'm going to do it again and get rid of the n this time. Copy. Paste. Now this is the way you ought to do your homework, copy and pasting back and forth like that, and makes it much easier. Okay, so now 45 is 5 times 9, and this guy here is 2 times 9, right? So if I multiply this guy by 2 and that guy by 5, then that would get rid of the n. Okay, so that's what I'm going to do. Okay, so 5 times 24 minus 2 times 36. 48. 48 over m equals 5 times 72 minus 2 times 116, 128. So m and it'd be 48 divided by 128. Okay, 48 divided by 128. Oh, you got a problem there?
How do you get negative 2?
I want to get rid of n. Okay, so I know that 5 times 18 gives me 90. And I know that 2 times 45 gives me 90. So, and I'm subtracting. So I'm subtracting to get rid of the n. So that's why I picked it. I didn't pick negative 2. I picked 2, and then I'm saying I'm subtracting. That's different than picking negative 2. Of course, I could have picked a negative 2 and said I was adding. That would have been the same thing. Okay, so I could have said, okay, ooh, that was not good. Come back. Okay, there we go. I could have gone and picked. Where the heck am I? I could have said I'm not subtracting, but I'm going to add, and I'm going to add by multiplying by a -2. I could have done that too. But in either event, what I'm doing is I want to get rid of one of the variables. That's the whole purpose of multiple equations, one unknowns, to get rid of a variable so you can solve for the other one. Anyway, back to what I was doing. Change this to a fraction. 3/8. I knew that. 3/8. All right. What problem was that anyway? That was 18. All right, it has to be right. Now, Maple ought to be able to solve this guy, right? So we can't look in the back of the book, but there's no reason we can't ask Maple. It's S-O-L-V-E, solve. And so I got 24 divided by m plus 18 divided by n equals 72, comma. And then I've got 36 divided by m plus 45 divided by n equals, oh, stupid me, equals 116. Close brackets, comma, and I want to solve for m and n. 3/8 and 9/4. Is that what I got? Yeah, 3/8 and 9/4. Okay, and we can go and do that. Oh, isn't that much better? Oh, it's just so much better. I guess it's not that much better, is it? No. Maybe. Is that better? Okay, now we got it all on the same line. Okay. So one more, and then we'll call it a day. Number 20. Number 20. Oh, bummer. Bummer is real. Look at that. A over x, which means Maple's not going to help us at all. B over y is equal to 2. B over x plus A over y is equal to 1. Okay. Okay. What we're going to do is we're going to multiply the top guy by A and the bottom guy by B, and then we're going to subtract. And that will get rid of the y term, because I'm going to have an AB over y minus AB over y. All right, so that's my plan. So I've got A minus A squared minus B squared over x. That guy goes away, is equal to 2A minus B. So x is going to be A squared minus B squared over 2A minus B. I really don't want to go and put that guy back into any of those equations to get the other answer, do you? Yeah, I don't want to do that either. Okay, so we'll do the same thing over again and get rid of the x term and find the y term. And copy. Paste. Alright, so now I got rid of the x term the first time. Now I want to get rid of the y term. Or I got rid of the y term. Now I want to get rid of the x term. Okay, so I'm going to multiply the top guy by B, the bottom guy by A, and subtract. Okay, so I got AB over x minus ab over x. He goes away. So I've got b squared minus a squared over y is equal to 2b minus a. And I've got y is equal to b squared minus a squared over 2b minus a. And none of that stuff factors out, so I'm stuck and I'm done. And that's as far as I can go. And it's problem number 20, which isn't even in the back of the book, so we can't even check to see if it's right. Oh, bummer. Okay, so check that guy, check this guy. We could put them back in the equation to check it, though, can't we? Why don't we do that? Oh. Sounds like a really bad idea. Does that sound like a bad idea to anybody? Okay, so we're going to take our answer and put it back in the equation and see if it's right. All right, so if I had a divided by x, a squared minus b squared, divided by 2a minus b. And I added that to b divided by y, which is b squared minus a squared over 2b minus a. And I'm supposed to get 2. What am I going to do about that? Okay, I think first thing I'm going to do is invert and multiply. So I'm going to have 2a squared minus ab over a squared minus b squared. And then I'm going to have minus ab plus ab minus b squared over a squared minus b, which is the same guy that I got there, is equal to 2. Okay, so these two go away, and I've got 2a squared. Oh, I can't possibly do that. What happened to this b? 2. I got 2a squared plus 2b squared. That's not going to work either. Now this is a minus sign. That'll work. This is a minus sign. That's better. I got this guy here is a minus sign. Divided by a squared minus b squared, which is clearly 2. So when I put that back in, it's going to check, isn't life wonderful? All right, Control Alt 1.